Hello, Algebra 2 students. This is Dr. Heron talking to you about Unit 2, Notes 4, talking about absolute value inequalities. And absolute value inequalities basically are going to act almost like compound inequalities, okay? So they're going to be compound inequalities. That means that they are going to either go towards each other or go away from each other. So to do this, you're going to solve your absolute value equations, and then you're going to do the compound inequality, okay? So what it ends up looking like is two similar inequalities, and then you're going to graph kind of what they look like, all right? So if it's greater, then it's going to be an OR problem, okay? Which means it's one or the other. So the way to think about it is great or, ends in or, is going to be an or problem. Less than means it's going to be an and problem. So for the and problem, you need to graph both inequalities and then just keep where they are set, keep where they cross, okay? So, and then when you graph it, you're going to turn it around for the inequality. All right, so let's look at what we're dealing with. So if I take this problem, what I'm going to do is I'm going to add 10, okay? So 2x minus 3, absolute value is greater than 5. All right, so now if I turn that around, split that, I'm going to have 2x minus 3 is greater than 5. And because it's greater, it's going to be or 2x minus 3 less than negative 5. So then I solve. So 2x greater than 8, x greater than 4. Over here, 2x less than negative 2, x less than negative 1. So it's going to be an or. So I'm going to have these two, and that's going to be my compound. So if I go 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, x greater than 4, open circle, out, x less than negative 1, open circle, back. There is my inequality. Okay, so you're going to take this and kind of go, is it going to be an or is it going to be an and then which way the graph's going to go? So when I look, you're going to have some unique situations. First off, you've got an absolute value equal to a negative number. All right, that is a big clue that there is no solution. Okay, there is no value I can put in there, get a negative number, and have it be negative 10. Similarly, less than or equal to less than equal 10. Again, that's going to be no solution. The reason behind that is, just like it can't equal a negative number, I certainly can't be smaller than that negative number. Okay? If I can't equal that negative number, I certainly can't be smaller than that negative number. C is a little bit different because everything I put in there is going to be greater than negative 10. Okay? So this is going to be all real numbers. All right? So this is all real numbers. This is going to be infinitely many solutions. Okay? Because everything I put in there is going to be bigger than negative 10. Okay? So if it's less, let's look at this one. So if it's less than, it's going to be an and problem. So I'm going to have 5x minus 10 less than 15, 5x minus 10 greater than negative 15. And this is going to be both and. So 5x less than 25, x less than 5. 5x greater than negative 5, so x greater than negative 1. So there's 5, there's negative 1. Less than negative 5 goes this way, greater than negative 1 goes this way. There is my solution. The one on the right, B. all right, is going to be negative 7x less than 14. It's less than, so it's going to be and then negative 7x greater than negative 14. Okay, so that means dividing by negative 7, x is greater than negative 2, divide by negative 7, x less than 2. So greater than negative 2 up to 2, there's my answer. This one gets a little more complicated, but that's fine. We can handle that. So I'm going to add 9, divide by 4, divide by 4. So now I'm here. If it's greater, it's going to be an or. So now I rewrite it 3x minus 6 greater than 9, 3x minus 6 less than negative 9. So 3x is going to be greater than 15, x greater than 5. Over here, 3x less than negative 3, x less than negative 1. All right, so on my graph, negative 1, 1, 2, 3, 4, 5. I'm going greater than here, less than here. For this one, yes, there's a fraction. Don't panic. Okay? This is doable. So I want to subtract 11. And get 6. When I multiply 4/3, that's going to cancel that out. So that's going to be 8. So I'm going to have 8x minus 16 less than 8. And 8x minus 16 greater than negative 8. So 8x less than 24, 8x greater than 8. X is going to be less than 3. X is going to be greater than 1. So 1, 2, 3. Open, open. There you go. Let's do this one. This one's a little bit different. So the first thing I'm going to do is add 35. So 2x plus 4 greater than 120. So then divide. So 2x plus 4, if it's greater than or equal to 40, or 2x plus 4 less than or equal to negative 40. So 2x greater than or equal to 36. So over here, 2x is going to be less than or equal to negative 44. So x will be greater than or equal to 18, or x will be less than or equal to negative 11. Not negative 11, negative 22. Weird. Okay, so this one really, really far apart. I just kind of eyeball. Yeah, that looks about like negative 18. Negative 22 is there. That's going to be about what that one looks like. All right, last problem. So I want to multiply by 4 first. Which should be 72. Add 3. Divide by 5. So that's absolute value of 10x plus 5 less than or equal to 15. Okay, so less than or equal to. So it's going to be 10x plus 5 less than or equal to 15, and 10x plus 5 greater than or equal to negative 15. So 10x less than or equal to 20, 10x greater than or equal to negative 20. So x is less than or equal to 2. X is greater than or equal to negative 7. That should just be x. So last step, 0, 1, 2, open circle back, 1, 2, 3, 4, 5, 6, 7, open circle forward. There's my answer. Okay, so you're simplifying, getting the absolute value alone, deciding if it's and or, and then solving and graphing appropriately. All right? Come talk to me with your questions.